Hi, this is John Wen. Today is June 11th, 2018, and this will be the second video to talk about the 3 SAT problem. Continue from last week, we were talking about to generate a 3 norm form formula and to use a brute force strategy and to find assignments to make the formula true. And this week we will continue the topic and project, and we will use a Targan algorithm instead of brute force strategy to find out the assignments to make the formula true. And let's go ahead and take a look at the code. So in the main.java, last time we focused on generate a third normal formula, and but this time we will use a second SAT parser to generate a second SAT formula instead, because we will use a graph, and based on this second SAT formula to generate a graph, and then to apply the Targan algorithm into this graph to find out the strongly connected components. We will introduce that later, but that's a rough idea. Let's go through the program first. So here we have our formula that is hard-coded into the program, and we pass this string to the formula second SAT parser. Let's take a look at this class. So in the formula second SAT parser, let's scroll a little bit. We have several instance variable defined in this class, and we have a constructor and take one string as input, and the string will be initialized, and several others will be initialized too, and there will be two array lists for variables and literals. So this is a basic constructor for the this class. So let's go back to the main.java, and we will see the new instance of this class will trigger the pass formula to a SAT function or methods. So let's go back to this class and scroll a little bit and to find that methods. So here it is. So pass formula second SAT, and this will returns a value type of formula second SAT formula. So this is what we want. Let's take a look what's going on inside it. So firstly, it will initialize a list of class second SAT and name it as class set. Remember, in last time when we generated a third normal form formula, and we will need 3 inputs into the class, that is a variable, literal, and class set. And here we see we declare the we initialize a class set first, and we also declare the class second SAT as C. So this is finally what we will return. So let's go ahead and oh sorry, this is not, this is only the class second SAT. So let's go ahead and see what's next. So for because we define a ch as a char, and while we read the string, and we will get the next char execute first. So let's take a look at the next char. What is next char? So plus plus position, remember the first position is -1, and if it is less than the strength, the length of the string, and we will get the next char. So otherwise we will get -1. So here we do the next char first, and then we will use eat function. Eat function is a boolean, but it will do firstly we'll check if it is space. If so, it will get next char, and if not, and we will compare the character with the input character or int, and so it will return the next char. It will get the next char, or if it is not the same, and it will get the false. Basically, it will like the get rid of this character if it exists, and here if we existed this character bracket, and we will find the next one, and we will check the next one, read the next one. So while C equals parse class, this function is not long, and let's take a look at the parse class function, and here it is. It also have to do some cleanup, like the brackets and the forward slash or slash, and the literal. So we here we have another function says parse literals. Parse literal is here. It is by checking whether this is has this symbol, and to define the boolean is positive or not. So basically, we will get the value of each variable in this literal, and then we will assign them back to the variable type of variable, and then add them to the variable list, and finally we will add them back to the literal with the value depends on the symbol we are detected. So this is a parsing work that basically to get the string and back to the object, or that the program will know what we are input. So this is a basic parts, and finally, while we finish up the literals, and we will put together literals and put in the class second SAT. Remember last time we put 3 literals into the class, every class, but now for we use a second SAT, and we only take 2 literals. So this is a basic what SAT parser does for us. So let's go back to the main, and while we get the formula ready, and we will put this formula as input and generate a graph. So in the graph class and graph.java, we will have several private instance variable defined, and here is a function constructor, and for Java has a overloading feature, and we have 2 kind of inputs, and one is a number of nodes, and the other is a formula SAT, second SAT formula as an input, and definitely we are in the second case. So in this case, we will initialize the instance variables, and to assign values like the the size of literals to the number of nodes, because we'll draw a graph, and depends on the literals we put. And also we will define a list, and this will be a adjacency list for each node. And firstly, we will initialize this list and to to an empty list of array. And for every class in this formula, we will get the first literal and the second literal, and basically we will connect them as in the edge in the graph. And here we have a negation method. Basically, it will flip the value. If it is a positive, and it will become the negative, and then flip the literals value, and then connect them each other with the other nodes. So this is basically what the graph will do for us. So we will get the literals connected. And let's go back to the main. And let's skip this printout first, and see this line first. So we will define, as we said, we will use a Targan algorithm as a solver instead of the brute force strategy as last time. And so we will initialize an instance of this class first and input this formula. So let's take a look at the Targan solver. What does it will do for us? And yeah, the input will be a formula second SAT, and it has several other methods like solve, and we will use this very quick. And right, so let's go back to the main and see what we'll do next. So in the main, here we have the solver initialized, and then we also define start time in order to record the execution time. So we will get a list of variables as vars, and and call the solve method in this instance. So let's go back to the solver and see what solve method does for us. So here is basically we will get all the variables and from the formula, and also get all the literals from the formula, and then we will generate a graph, and it's in the graph class, and then the graph we will call the getSCC method. So let's go back to the graph class, and in the graph class we have the generate SCC methods, and basically we'll call the Targan and put with the list of earliest. Remember, earliest is a adjacency list of each node. That means the neighbors of each node. And then once this initialized, and we will call the getSCC method from Targan class. So let's go to the Targan class and see what's inside. So yeah, it has more instance variables defined here. Here we have number of nodes in the graph. And also we will have a pre-number, and that is a counter, because we have to assign the index to each node, and we will have a low link, and this will be a value will be initialized same as the index at first, and then will be compared and with the connected nodes if the nodes that is reachable is lower than the node we are at, and the low link value will be updated, and once every node will be visited once, and once the node's neighbor has been visited all, and then the nodes with the same low link value will be counted as a strongly connected component and will be popped up from the stack. So that is the basic idea of the Targan algorithm. So let's take a look at, we have a list of Boolean will define the nodes whether it has been visited. Remember, we only visit them once. And we have a list that defines the list of adjacency list of each node, and also we will have a SCC. This is a final strongly connected components we want to get, and the type of it is a list of integer. And of course we will need a stack to push the nodes and or pop up the nodes. So here is a Targan's constructor. So it will initialize a list, and also assign the a list length to the number of nodes. So here is what we see. We will call this method getSCC, and firstly it will initialize the low link as a int array, and array length is n because we have n nodes, and the visited will also be a array, and the stack will be defined as integer stack because we will push index of each node into the stack and popped it up, and SCC will be array list. And firstly we will define the pre-number is 0, and because we will arbitrarily choose 1 as a starting node, so we will start from 0. And firstly we will initialize all the visited value is false, because once we visit it we will mark it as true. And if then we will check by each node if it is not visited, and we will implement the DFS methods on this node I. And finally we will return the SCC as strongly connected components as a list of integer. And let's take a look at the DFS, what DFS does for us. And the input is index of the DF on the nodes. And firstly we will define the low link. Low link is firstly will be initialized as an index, because we know the index will increment based on the pre-number, and each one will increment by 1, and then we will mark the visited of this node as true, and we'll push it into the stack, and we will we will assign the main value, the low link value to the main, and for every neighbor in the adjacency list of this node, and we will visit, if it is not visited, and we will visit it by the depth first search. And if the low link of the neighbor is smaller than the mean, that means we will update the mean to the neighbor's low link. That means we will find out the smallest the neighbor's smallest low link value. Then we'll assign it to the mean variable. And finally, after we visit all the neighbors, and we will compare this mean value to the low link value of this node. That means we will find out any of the smallest neighbor's low link value, and then we will assign this low link value to the nodes of our node's low link value. So, and otherwise, if our low link value is equals to the mean value, that means we are at the root of the strongly connected component. So that means the strongly connected component is ready to pop up from the stack. So here, this part we will do the so we will define a component as a list of integers, and we will pop up the index from the stack until the root is popped. So this one, while we will use a do while loop, and until we visited the root node. So, and then we will add this component to the strongly connected component or list. So finally, this list will contains multiple lists of index, and each of them are strongly component in the graph, like in the tree. So this is a basic idea of what Targan algorithm will do for us. So let's go back to the solver. So so it will generate a get SCC, and then for every variables, we will set the variable values to -1, and then we will adjust it in the following methods. So firstly, we will define a Boolean is successful, and for every every component in the SCC, remember we just get that strongly connected components as a list of index, and for each list in this list array or list of list, and we will try to find out whether if it is if the first of the literal has been already has been assigned, or has assignment that is not equal to -1, because remember we initialize and set them as -1, and we will use continue to skip the rest of code. So, and then we will go back to the next one. in the list. So otherwise, we have to check in the list, and for every integer or for every index in the list, and we will get the literal of the list. And if the literal is positive, and then we will make it positive literal true. So we will assign the get variable get variable of this literal method literal, and then set the value to 1 and assign to the exact is successful. Basically, based on the value of the literal, we will set it to 1 or to 0 in order to make the literal true. But while we have some we are using the x and the minus x at the same connected component, so that will cause a conflict. So we also give another option, because it could be the is successful could be false at final, so we will return the null. Otherwise, we will return the variables that makes the literals true. So let's go back to the main method, and here we are reaching to here. So we finish the solve, and the solve will returns the var, and here we have a statement that is to check if the vars equals null, and it will print out the formula is not satisfiable. That means if the vars, like what we said, if there's a conflict, just like x and minus x is both in the same connected component, and it will return null because the formula cannot be made true. And otherwise, and we will print out the var variable, and to get each of them from the get the variable method class, there is a method called get variable name and also get variable value, and we will print out them. So this is a basic idea of what this program will do for us. And we skip 2 lines here, and first one is get SS from the graph, and the second one is we can transfer this to the literals. So we can take a look at them from the result. Maybe that's better. So let's run this program. So firstly, we will get the get SCC method run from the graph class, and will returns the index list, a list of index. And if we run the formula class, there's a method called SCC2 SCC literals, and it will get returns a list of literals. So this is a difference, and we can take a look at them basically in the graph. And there is a get s. So this is get ss. So basically, it calls the Targan, and Targan will call the get SCC method, and this will return just index of each of them. But if we go to the second formula second SAT, and we will have a method called called the hold on second. Let's try. Yes, here SCC to SCCL literal. So this input is a SCC list. So it basically it will find the actual list. It will get by the index and will get the literal, and then it will be separated by comma and to put back to the list. So basically this is the idea of this program. And finally we can find out whether we can find any list of variables that can make the formula true. If not, it will returns the formula is not satisfiable. Just like this case, we get formula is not satisfiable because we have the x and minus x in the same connected component. So this is overall the basic idea of this program, and maybe I missed some many things that's very important, but this is what I've learned and worked on in the past week, and hopefully we can get better version in next week and better understanding. And we have another part of code, and we just comment or change something and it does not wrong, and just it still be a 3 SAT problem and use a brute force strategy to solve it. And maybe we can take a look at it at next time. But yeah, overall it's a introduction of today's contents, and maybe we can get much better understanding. And next time, until then, happy coding. Thanks a lot for your time. Okay, bye.